application part with what are the social benefits of this data and the applications. And to start this part, I will call Estelle Obligis from EUMETSAT.
So good morning, everyone. We will go back a little bit with the observations of the ocean, with what we do at EUMETSAT. So EUMETSAT is an intergovernmental organization with 30 member states, and our primary objective is to establish, maintain, exploit European systems of meteorological satellites. And a further objective is to contribute to the operational monitoring of the climate, and for that we need to observe the ocean. What we do as a value, this is very important, and it was shown in a recent report published in 2023 that in terms of risk of disruption for the 10 coming years, at the first 4 places, you can see that we have environmental risks. The first one is extreme weather events and critical change to Earth systems, biodiversity loss and ecosystem collapse, and natural resource shortages. So this is key to observe our environment, and the ocean in particular. So we observe the weather, the Earth and the ocean with 2 families of satellites at EUMETSAT. We have our geostationary satellites flying at a high altitude, and it allows to observe a specific region of the globe with a high frequency every 10 minutes. And we fly as well polar satellites that sample progressively all the Earth and all the ocean. So just to show you a beautiful image of our last baby. So this is from the MTG satellite, the first image processed from the FCI instruments. Then I wanted to show you an animation just to illustrate the power of the Earth observation from satellites. So we are talking here about atmosphere and weather, but it's quite easy to extrapolate to the ocean. So here you have an illustration showing a big flow of air coming from northeast on the Canary Island. And after the island, you see the formation of this Kármán vortex, what we call vortex streets, on the other side of the island, with a very, very accurate description thanks to the satellite. So here you have one image every 10 minutes. So now we move to the ocean. So we can observe the ocean, we can observe the sea level, we can observe the sea state. So this was presented by Lotfi, so the waves, the wind. We can observe the sea surface temperature of the ocean, we can observe the color of the ocean. We can observe the sea ice, for example, and its evolution in time. We can observe the erosion, or we can observe big storms, hurricanes, and so on. So at EUMETSAT, we have a growing integrated stream of marine products coming from different kinds of satellites, instruments. So the first one is the family of the scatterometers that fly on our polar satellites to retrieve the wind vectors and the sea ice parameters. Then we have as well infrared radiometers for surface temperature and fluxes. We have altimeters, it was described already, for sea surface height, but waves and wind speed as well. And we have visible radiometers for ocean color. Very soon we will have new families with a salinity, with a simmer mission as presented already by Jacqueline. And all these parameters, of course, are key for some downstream applications like operational oceanography, numerical reserve prediction because of the coupling between the atmosphere and the ocean, marine meteorology, climate analysis, marine ecosystem monitoring. So just one slide to show you what is done by the OSISAF. The OSISAF is the Ocean and Sea Ice Satellite Application Facility at EUMETSAT. So on this plot, you can see the variation of the Arctic sea ice extent. So you have the annual cycle from January to December, and then you have the evolution of the sea ice extent, starting in 1980s with a purple curve until 2024 with a black curve. So you can see very well the decrease in terms of Arctic sea ice extent. And another illustration showing the annual cycle of the sea ice extent around Antarctica. Now coming to the altimetry missions and to the sea level. So thanks to all these missions that have flown since Topex Poseidon in 1992, we have been able to build this sea level record, global sea level record. And thanks to all these missions, we can estimate an average trend with 3.3 millimeter per year and with significant acceleration today. So thanks to this series of 30 years of reference altimetry mission, we know that sea level rose on average by 10 centimeters over the last 30 years, that the trend was 2.1 millimeter per year in 1992, but in 2022 it was almost twice higher. And if unabated, the sea level will rise by 68 centimeters over the 21st century. Of course, building something like that presents considerable challenges in terms of precision of the instrument, accuracy, stability, quality of the processing, coverage of the measurement system. And in terms of data availability, reliability, standardization, and know-how. And this should include capacity building and so on. So just an image showing that we do we monitor the global sea level rise, but we do geographical, regional sea level rise as well. Now we move to the ocean color. So we have two satellites fully operational from Copernicus, so Sentinel-3 and Sentinel-3B. And you see on this animation the evolution of the ocean color, so the chlorophyll for 1 full year. So of course, monitoring of free-floating photosynthetic organism is key. Key to study the marine ecosystem, to monitor the water quality, and to monitor the biodiversity as well. The winds over the ocean with our scatterometer, so just 3 images to show you how we observe the Hurricane Milton in October 2024. So this is very important. So we can observe, of course, the hurricane, but we can as well, through assimilation, forecast the intensity and the trajectory of the hurricane. So my last slide for the conclusion. So we have now mature marine observations from space with really an increasing scope. We're starting mainly with physical oceanography. Now we do environment monitoring, climate monitoring, weather predictions through the coupling between atmosphere and the ocean. There is, of course, an increasing societal impact and demand. So from blue, so which is the physical ocean parameter, to green, biogeochemistry, aquaculture, biodiversity, and white economy, for example, for high latitudes. We went from research to operational services. Today we have numerical modeling with commensurate IT resources, and this is really a big change. We are able to use high resolution measurements, big data volumes, into coupled models, and this is thanks to these IT resources that are available today. A big game changer in the coming years will be, of course, the artificial intelligence that will help in the retrieval, in the monitoring, in the assimilation, in many parts. Something else which is very important is that we have sustainable long-term and international space program. So it means we have a visibility, like with Copernicus, for example, we have a visibility up to 2050. And I think this is a good place and a good moment to highlight that everything that we build to observe the weather and the ocean, of course, has been done thanks to the collaboration between international space agencies and between international science team as well. So this is key that we try to keep really this work, keep doing this work all together. Thank you.
Thank you, EUMETSAT, for this presentation of EUMETSAT activities. That has a very important role in transforming all the scientific work we saw in the first part into operational product that allows applications.